take one. First take. Whenever you're ready. Open
Okay, 3, 2, 1, go.
space.
Okay, so the question says find values a, b such that f of x has a local extremum at the point x equals -1 and another local extrema at x2 equals 1. So these are extrema, -1 and 1. Afterwards, okay, we'll do that afterwards. So you have the equation, and when you read in the question the local extrema, you think that's when the derivative has to be 0 because it's an extrema. So we take the derivative of this and set it equal to 0. Okay, let's go. So 3bx squared plus 2ax minus 6. And you set it equal to 0 because that's where, when the derivative is 0, that's where it's at the extrema. All right, now we need to find the b and a that get us there. So we go down every possible path, and this will come to an end very quickly. If we set b equal to 0, we'll soon realize we can only ever get one answer. If a is some arbitrary value like 3, trying to get as close as possible to these x values, then we'll get 6x equals 6 when that moves over, and x equals 1. And if this is -3, this will be -1. So we can only get x equals -1 and x equals 1. And we think to ourselves, okay, if only there was something that can give us two answers at the same time, like this squared. So this can't be, b cannot be 0. That's how we know b can't be 0.
Yep.
So b has to be greater than 0. If a is also greater than 0, then we have to think about what will happen. This term will give us plus or minus some value. And then this will go to the other side when we set it equal to that. And then this will shift it. So it will be like -5 and 8. The magnitude of the two values won't be the same. They'll start over here, equidistant from 0 on the number line, and then this term will shift them. So since we know that the magnitude of this is equal to the magnitude of this, then that's how you notice
Of what?
the magnitude of -1 is equal to the magnitude of 1.
Yeah.
So these are equidistant from 0. That's how you know. That's how you notice that a actually has to be 0. Once you notice that and a is 0, then you solve for b. So 3bx squared equals 6, and you divide by that. Bx squared equals 2, and then given that x equals positive or -1,
X values.
b equals 2. So that it gives you this. b is 2 is the only value that gives you. Yeah. Okay. So we should do it this way. b equals 2, right? So then you divide by 2 and get x squared equals 1. X equals positive or -1. That's what this is. So a is 0 and b is 2. And then if we go to part b, specify whether the points are local maxima or local minima. That's done by taking the derivative again to determine the concavity. Oh, this is longer. I have a minute. Okay. So take the derivative again of this. I mean, -6 is going to go away. So 3 times 2 is 6x squared. 6x squared, the derivative is 12x. If you plug in positive or -1, if you plug in -1,
yeah,
then this is the derivative. If you plug in -1 for x, the second derivative will be negative, which means it's concave down. If you plug in +1 for x,
that's the max.
the second derivative will be positive, concave up. So this one corresponds to concave up, meaning it's a min. And this one corresponds to concave down, because it makes the second derivative negative, meaning it's a max. And then, yeah, That's 5 minutes. Whoa.
Also, 5 minutes doesn't matter here.
Yeah, for the clip. You have to clip it.
No, I don't have to clip it. It's a video I'm recording.
Oh, I thought we had to do this in 5 minutes because you had to clip it.